Hello students, good morning all of you. Welcome to this online class. So today we are going to discuss about the lateral ventricles and as well as the third ventricle. So let me show you this lateral ventricles. What is the exact location of the lateral ventricles and from where to where they are extending and what are the parts of it. These are all the things we are going to discuss. Okay, so coming to this, the lateral ventricles. There are two lateral ventricles, one in each cerebral hemisphere. Each lateral ventricle is a roughly C-shaped cavity situated within each cerebral hemisphere. Okay, so coming to see this lateral ventricles. Okay, so now we are seeing on in this picture the cerebral hemisphere, right and left cerebral hemisphere. Now we are looking this from the lateral aspect, so we can identify the left lobe of the brain, lobe of the cerebrum. In this cerebrum, we can identify this space is nothing but the ventricles, lateral ventricles. So location is in each cerebral hemisphere, we can identify the spaces, cavities. They are nothing but the ventricles. Okay, so this brain is bathed by cerebrospinal fluid. Then inside the brain there are spaces or cavities that are filled with the cerebrospinal fluid. They are nothing but the ventricles. There are four ventricles. There are two lateral ventricles in each cerebral hemisphere. Then the two lateral ventricles they are opening into the third ventricle, which is present at the middle part. Medially, we can identify this third ventricle, and the third ventricle it is opening into the fourth ventricle through a duct called as cerebral aqueduct, whereas the two lateral ventricles they opens into the third ventricle by interventricular foramen of Monroe. Understood? So the two lateral ventricles opens into the third ventricle through a foramen called as interventricular foramen of Monroe, whereas the third ventricle here it is opening into this fourth ventricle through cerebral aqueduct. So the fourth ventricle is between the pons and open medulla and the cerebellum. Okay. The third ventricle, which is present in the diencephalon, the two lateral ventricles, they are present in cerebral hemispheres. Then moving to this lateral ventricles. What are the lateral ventricles and what are the parts of the lateral ventricles that we are going to explore now? So the lateral ventricle wraps itself around the thalamus, the lentiform nucleus, and the caudate nucleus. Okay, so what are these lentiform nucleus? What is this caudate nucleus? And what is this thalamus and all? They are subcortical nucleus, basal ganglia. Okay, basal means below the cortex. We can identify the gray matter collections. They are nothing but basal ganglia. These are the examples of the basal ganglia. What are the examples? Thalamus, lentiform nucleus, and caudate nucleus. They are nothing but the basal ganglia. So this lateral ventricle is surrounding the basal ganglia. Now you can see this cerebral, okay, this lateral ventricle which is surrounding this area surrounding the basal ganglia. Understood now? So just wait for a while. Now coming to this parts of the lateral ventricle. So coming to the parts of the lateral ventricle, and the description about the lateral ventricle is it is lined with ependyma and filled with cerebrospinal fluid. It has a capacity of 7 to 10 ml of cerebrospinal fluid. Okay, the main parts of the two ventricles are separated from each other by a septum extending between the corpus callosum and the fornix called as septum pellucidum. Understood now? So the septum pellucidum is a thin vertical sheet of nervous tissue constituting of the gray and white matters and covered either side by ependyma. Understood? So the septum pellucidum is a layer which is present. So the septum pellucidum. So I just want to briefly explain about this septum pellucidum. Again, when we are going to discuss about the third ventricle, we will discuss in detail. So the septum pellucidum is a thin sheet. It is a thin vertical sheet of nervous tissue consisting of both gray and white matters, and they are covered by either side by ependymal cells. Understood? So these two lateral ventricles they opens into the third ventricle. Understood? So that is the major thing you have to remember. Then coming to the parts of the lateral ventricle. Coming to the parts of the lateral ventricle. So the parts of the lateral ventricle are one is yes. Okay. So coming to this, and it is having three horns. One is anterior horn. Anterior horn, which is extending extending from the central part into the frontal lobe. Extending into frontal lobe. So here you can identify there is anterior horn. Then it lies in front of interventricular foramen. You can identify. So it is lying in front of interventricular foramen. So this is nothing but the anterior horn of lateral ventricle. Okay. And behind it is behind the posterior surface of genu of corpus callosum. Behind behind it is the posterior surface of genu of corpus callosum. Then coming to the posterior horn. So the posterior horn is a backward extension from the central part or central body, and it extends into the occipital lobe. Okay, occipital lobe towards the occipital pole of cerebrum. Then comes the inferior horn, which is direct continuation of the main ventricular cavity into temporal lobe. The inferior horn is the largest of the three horns. It begins where the central part and the posterior horn meets. It begins here where the central body and the posterior horn meets. So it is a elongated one when you compare with the posterior and anterior horns. It is curves around the pulvinar of thalamus. What is pulvinar of thalamus? We will study when you are going to discuss about the thalamus. Remember, it is curving around the pulvinar of thalamus and extends into the temporal lobe to end of 2.5 centimeters behind the temporal pole. Okay, that is about three horns of lateral ventricle. Then coming to the central part or central body is lies mostly within the parietal lobe. It is a C-shaped part. We can identify it as a C-shaped part which is present in the parietal lobe and extends from the interventricular foramen in front and the splenium of corpus callosum behind. Okay, so in front in interventricular foramen of Monroe, whereas behind behind we can identify the splenium of corpus callosum which is present over here. Okay, approximately it is present over here. So that is about the four parts of the lateral ventricle. So now we are going to discuss about each and every horns and what are the structures present surrounding that parts that we are going to discuss now. First we are going to discuss, so this is the superior view of the ventricular system. We can identify the lateral ventricle over here and the anterior horns which are present in front into the frontal lobe, then the posterior horn in the occipital lobe and inferior horn in the temporal lobe, and body is in the parietal lobe. Okay, the inferior and the posterior horns are connected in the trigone. So inferior and the posterior horns They are connected in the trigone. This is the part called as the trigone. Then we are moving to the lateral ventricle, anterior horn. So anterior horn of the lateral ventricle, what are the structures are present in the anterior horn? Or first, the anterior horn of each lateral ventricle extends in front of the in front of the sorry, it is extends into the frontal lobe. It extends into the frontal lobe, and it is having roof, then floor, anterior, and the relations, anterior medial relations and lateral relations. Okay, so we are going to discuss about the anterior horn of the lateral ventricle. So anterior horn of lateral ventricle, which is extends into the frontal lobe forward, laterally downward and up to the genu of corpus callosum. Genu of corpus callosum. On coronal section, it is roughly triangular in section, triangular in structure. It presents roof, floor, anterior and medial walls. It presents roof, floor, anterior, then medial walls, anterior and the medial walls. So roof, it is formed by the trunk of corpus callosum. Roof is formed by the trunk of corpus callosum. Floor is formed by corpus callosum rostrum part of corpus callosum. Okay, so here you can say the rostrum, then the roof is formed by the trunk of corpus callosum. Then anteriorly we can identify the genu part of corpus callosum, and medially we can identify this septum pellucidum. So what is the septum pellucidum? We have discussed septum pellucidum is a thin vertical sheet which is consisting of both gray and white matters. They are covered on either side by ependymal cells. Ependymal cells. So that is the medial relation of the medial relation of the anterior horn of the lateral ventricle. Then, so yes. Then coming to this other parts of the lateral ventricle. Excuse me. So that is about the anterior horn of the lateral ventricle. So one more relation, what we are going to see here are, so the floor part. So the floor which is contributed by the rostrum part of corpus callosum, that is here, which is present over here, the rostrum part of corpus callosum. So if you just look at this image, yes, here you can identify. So the lateral part of the floor, which is contributed by the head of the caudate nucleus, that which it is also involving in the formation of the floor of the anterior horn of lateral ventricle. That is about anterior horn. Then coming to the body or central part. So coming to the body or central part, so the body extends from the interventricular foramen to the splenium or corpus callosum. To the splenium of corpus callosum. On coronal section, it is somewhat triangular, and presents roof, floor, and medial wall. Okay, so it is presenting roof, floor, and the medial wall. So it is present in the from the interventricular foramen of Monroe to the splenium of corpus callosum. Then coming to the parts roof, floor, and the medial wall. Roof is formed under surface of the body of corpus callosum. Roof, which we can identify over here. Okay, roof is formed by under surface of the body of corpus callosum, whereas the floor slopes downwards and medially. So that I will try to show you here. So it is the floor which is downwards and medially, which is present like this. Okay, this is the roof and this is the floor, and here you can see the medial wall. So coming to the floor, it is sloping downwards and medially. From lateral to medial, what are the structures are present for? One is body of caudate nucleus. Here you can see this. This is nothing but body of caudate nucleus. Then we can identify two structures called as stria terminalis, and thalamostriate vein. Thalamostriate vein. You try to write down the structures. Try to write down the structures. I'm not projecting on the screen, but I'm just telling you other two structures which are involving in the contribution of the floor of the central body or central part. One is caudate nucleus, and just medial to the caudate nucleus we can identify striae terminalis. Then we can medial to the striae terminalis we can identify thalamostriate vein. Thalamostriate vein we can identify. Then lateral part of upper surface of thalamus. So this part is called as thalamus. Lateral part of upper surface of thalamus, which is present here, and it is also involving in the formation of the floor of the central body. Then choroid plexus covering the medial part of the upper surface of the thalamus. Here you can identify the choroid plexus. Choroid plexus covering the medial part of the upper surface of thalamus. Then upper surface of body of phoenix. Upper surface of body of phoenix. So these are all the structures which are involving in the formation of floor of the central body. Then coming to the medial wall is forming the septum pellucidum. And coming to the lateral wall is very small. Okay, so lateral wall is very small, a narrow area. So where it is joining the roof. So here you can see that it is very narrow part, which is the narrow area which we can identify roof and floor are joining with each other. Remember, roof, floor, medial wall. Lateral wall is negligible. Okay, we need to remember this lateral wall. We can just say that roof and floor where they are joining with each other, that itself it is forming the lateral wall of the body or central part. Okay, that is about the central part. Then coming to the posterior horn of the lateral ventricle. So the posterior horn is a quadrangular. Posterior horn is quadrangular or diamond shape in coronal section and presents roof, floor, lateral wall, and the medial wall. Let me show you all these parts once again. So this is having four things: roof, floor, lateral wall, and the medial wall. Okay. Then there are two elevations. One is bulb of posterior horn formed by forceps major 2, then calcareous produced by calcarean sulcus. Okay, so just want to show you all the structures in this image. Another image I just want to show you. Just wait for a while. Yes, coming to the posterior horn of the lateral ventricle. As we have discussed, it is extending into the occipital lobe actually. Then the features of the posterior horn are, it is having roof, floor, lateral wall, and the medial wall that we have discussed earlier. So coming to the roof and the lateral wall form a continuous convex surface. Roof, roof and the lateral wall forming the continuous lateral surface. So that is how the roof and the lateral wall, they are convex. Okay, roof and the lateral wall convex. They are continuous with each other. Continuous with each other. And here you can see this roof and the lateral wall. Okay, roof and the lateral wall. And this here we can identify the fibers of optic radiation. These are the fibers of optic radiation pass along this surface, separated by tapetum, tapetum of corpus callosum, tapetum of corpus callosum. Then we can identify the medial wall and the floor of the posterior horn are continuous, whereas the roof and lateral wall are continuous. Then floor and the medial wall, they are continuous. Then the floor and the medial wall of the posterior horn are continuous and exhibit two elongated elevations. Let me show you this elongated elevations in this image. Yes, here you can identify two elevations. Okay, so the upper elevation known as the bulb of the posterior horn. Bulb of the posterior horn, that is formed by, it is produced by the fibers of forceps major which pass through the splenium of corpus callosum. Then the lower elevation, here you can see this calcareous, lower elevation. This elevation is called as calcareous. It is formed by inward projection of anterior part of calcarine sulcus. Okay, inward projection of anterior part of calcarine sulcus. So that is about the posterior horn of the lateral ventricle. Okay, posterior horn of lateral ventricle. Then coming to the inferior horn of the lateral ventricle. Coming to the inferior horn, it is the longest of the three. It first extends backwards and laterally around the pulvinar end of thalamus, around the pulvinar end of thalamus. Thereafter, it proceeds downward, forward within the temporal lobe, deep to and parallel with the temporal sulcus. Superior temporal sulcus. And the features of the inferior horn are: it is having roof. Roof is formed by tapetum. Roof is formed by the tapetum of the corpus callosum and the caudate nucleus, tail of caudate nucleus, then amygdaloid nucleus, and striae terminalis. These are the structures which are forming the roof of the inferior horn. So, roof is formed by tapetum of corpus callosum. Then medial part of the roof is formed by tail of the caudate nucleus, amygdaloid body as a continuation of the tail in the anterior part of the roof, and striae terminalis, which forms a projection bundle of the amygdaloid body. So that is about the roof. So here you can identify all the features of the roof: tapetum of corpus callosum, then somewhere here the tail of caudate nucleus. Okay, tapetum of corpus callosum, tail of caudate nucleus, striae terminalis you can identify over here. Then little medially we can identify the amygdaloid body. Then coming to the floor of the inferior horn, which is formed by hippocampus. Then you can identify fimbriae of hippocampus and collateral eminence, and the lateral wall is formed by tapetum of corpus callosum. So the floor is formed by hippocampus. Yes, here you can identify the hippocampus. So I just want to show you another diagram in the PDF. Just wait for a while. So here you can see this. Yeah, here you can see the hippocampus over here. So this hippocampus, which is the forming involving in the floor of the lateral ventricle, floor of the, yes, here you can see this inferior horn, temporal inferior horn. Here you can see this is the inferior horn. Then here you can see the hippocampus. This part is nothing but hippocampus. Okay, then other structures which are forming the floor of inferior horn. Coming to this floor of the inferior horn, and then coming to the lateral wall which is formed by tapetum of corpus callosum. Lateral wall is formed by tapetum of corpus callosum. This is about the inferior horn and the posterior horn, anterior horn, and the central body. So these are the things you have to remember at the ventricles, lateral ventricles. Then coming to the third ventricle, which is third ventricle, which is consisting of both gray and white matters, and they are lined by ependymal cells. Just briefly we'll discuss about this third ventricle. So as we have discussed earlier, it is a small space, so it is lined by both gray and white matters, and they are lined by ependymal cells. Okay, so coming to this, it is a slit-like cavity. Those lateral ventricles are formed by the thalamus and the hypothalamus on either side. At the rostral margin of the midbrain, the cerebral aqueduct of Sirius, it opens into the third ventricle. Okay, so then let me show you about this, the roof of the ventricle, roof of the third ventricle. So it is formed by pia ependymal cells, then which spans between the two striae medullaris thalami situated along the dorsomedial border of the thalamus. Okay, then we can see that the rostral part of the third ventricle lies an aperture called as interventricular interventricular foramen of Monroe. Here you can see this interventricular foramen of Monroe, which is located between the column of fornix and anterior pole of the thalamus. Okay, column of the fornix and anterior fornix of thalamus. So here you can see the hypothalamic nuclei, and here you can see the thalamus. Okay, so here approximately, so this is the third ventricle which we can identify over here. Okay, then topographical anatomy. How can we identify? The third ventricle is a midline slit-like cavity. Okay, so blindly you can remember that the lateral walls of the third ventricle is formed by thalamus and the hypothalamus. So this is the lateral walls of the third ventricle is formed by thalamus and the hypothalamus. Then caudally we can identify cerebral aqueduct of Sylvius. Through that, the third ventricle is communicating with the fourth ventricle. Okay, so remember roof, floor, and you can see the lateral walls over here, and the caudally it is communicating with the fourth ventricle. So that is about the third ventricle. Then the interventricular foramen of Monroe, which is provides the communication on either side with the extensive lateral ventricles located within the cerebral hemisphere. Okay, so that is the end of this lateral ventricles and the third ventricle class. I just want to show you one video. So how the cerebrospinal fluid after produced by the choroid plexus, how it is entering into this ventricles. I just want to show you. Please bear with me. Yes, let us see the video of cerebrospinal fluid. Supplies nutrients to the surface region. It is produced in the choroid plexus, shown here in red, which covers the floor of the lateral ventricle and the roof of the third ventricle. The CSF flows from the choroid plexus through the body and tail of the lateral ventricle and into the third ventricle. So here you can see the interventricular foramen of Monroe. Through that, CSF then flows to the fourth ventricle and via the cerebral aqueduct, exiting via the medial and lateral apertures. CSF exiting the lateral apertures flows to the pontine system on the ventral surface of the brainstem, while flow from the medial aperture enters the cerebellomedullary system. It then follows one of two paths. So this is how the cerebrospinal fluid, which is flowing. So after the circulation, the first flows around the cerebellum, draining into the superior system, from where it flows to the interpedunculaire system. The second path flows down the subdural space. So this is the second path called the lumbar system. Lumbar system. That is cerebellar system, and here you can identify the lumbar system. CSF then flows back up the spinal cord, and it joins the flows from the fourth ventricle and the superior system. Yes, here you can see the superior system. From the ventral systems, CSF flows across the cortical surfaces in the subarachnoid space, draining into the superior sagittal sinus via the arachnoid granulations. It then flows down the posterior surface towards what's called the confluence of the sinuses, where it joins the venous blood flowing from subcortical regions by the straight sinus. Thank you, students. So you try to study once again and try to prepare notes for you. Okay, so that will be helpful in your examinations. So all the best to your students.